All right, so getting into our third lesson here in our transformations unit, looking at translations, lateral movements. Warm up here is just practicing naming ordered pairs for these points, because that's going to be a big part of today, being able to name those pairs. So I'm going to go through and just list what these points should be. So A should be at 0, 11. B should be at 9, 3. C, if you name that, you should get 5, negative 9. D, you should have negative 5, negative 9. And point E is at negative 9, 3. Okay, if we go down to the next page, this short activity, just getting used to identifying movements, moving up, down, left to right, finding the turtle's way through his maze. In other words, if we started the turtle, he went down 1, this is the path through the maze. So down 1, right 1, down 1, 2, right, or sorry, left 1, down 1, right 1, 2, 3, 4, 5, 6, and so on until he found his way through the maze. And he would go down, then right, down, left, up, right. Oop, I made it to the wrong turn. Going too quick. Got myself stuck in the maze. Sorry, let's go back here. So from here, this point here, we went left 2, down 1, left 2, up 1, left 1, up 1, left 1, down 2, left 1, down 1, right 1, 2, down 1, right 1, down 1. And there we go. Found our way through the maze. So again, only point here is just recognizing movements, which direction you're going, counting how many units we moved. All right, so looking at translations now. So it says trace with patty paper for this activity. Doing this digitally recording, I can't do that for you, but with translations, we're just sliding, moving, so we can actually just count units and do it pretty well without patty paper for as far as translations go. So it gives us this figure W with points A, B, C, D, E, and F. And question A says translate the figure down 6 units. So if we were to go down 6 units, all that's going to do is move each vertice down 6 units. So in other words, if this is point B, if we count down 1, 2, 3, 4, 5, 6, it'd be here. Point A, I'm going to put in red, 1, 2, 3, 4, 5, 6. Point C, again, if you move down 6, count 6, we're going to be here. Point F, if we move down 6, we're going to be right here. Go to black. Point E, if we move that 6, we're going to go down 1, 2, 3, 4, 5, 6. We're right here. And I'll do another blue one. So point D, again, down 6 units, and that's going to put us about right there. So if I were to trace our figure now, see how good I can trace, it would look about like this. Closest to a straight line as I can draw there. All right, so we did part B, we drew the translated figure on the coordinate plane. Part C, did the translating figure W vertically change the size or shape? No. It remains congruent. Remember, transformations, rigid motion transformations do not change congruency. So if we're going to complete the table of ordered pairs, our new point, point A, our new A, is going to be at the point 2, negative 1. Our new B is going to be at the point 2, negative 5. Our new C is going to be at the point 4, negative 5. Our new D is going to be at the point 6, negative 3. Our new E is going to be at the point 6, negative 2. And our new F is going to be at the point 4, negative 1. So there would be all the coordinates of our new figure. So compare the coordinates of the new figure W with the coordinates of our pre-image figure W. How are the values of the coordinates the same? Well, the X was unchanged because we did not move left or right. The y decreased by 6 because we moved down 6 units. Okay, moving to the next page, says now let's investigate translating figure W horizontally. So now it's wanting for A to translate that figure 5 units to the left. So again, let me zoom in here. I'm going to use colors again. Point A, 1, 2, 3, 4, 5. Point B, same thing, go 5 left. Point C, 1, 2, 3, 4, 5. Point F, 1, 2, 3, 4, 5. E, 1, 2, 3, 4, 5. And then point D, I'm going to go back blue again, 1, 2, 3, 4, 5. So again, I'll try to trace it as best as straight lines I can draw here. And there is our figure, our new figure, translated 5 units to the left. So again, C, did translating the figure horizontally change the size? No. Remains congruent still. So if we're going to complete the table for our new points here, our new A value would be -3, 5. Our new B value would be -3, 1. Our new C value would be -1, 1. Our new D value would be +3, 1 +3. Our new E value would be at 1, 4. Erase that. 1, 4. And then our new F value is at -1, 5. So there's our table with our new pairs with that translated 5 units to the left. So compare the coordinates of figure W, new figure W with the coordinates of our pre-image figure W. How are the values of the coordinates the same? So X decreased by 5 because a movement to the left on the x-axis is decreasing, getting smaller. And the Y unchanged because we did not change vertically up or down on the y-axis. So 3, make a conjecture about how a vertical or horizontal translation affects the coordinates of x, points of x, y. All right, so a vertical I lost all my points again. Oh well. Vertical. I'll go back and fill in above later and post that. So vertical, in terms of x and y, x is unchanged. Y changed by some constant. So if it's negative, it would move it down. Positive would move it up. Horizontal. The x would change by some constant, and the y would remain unchanged. So there's how we could affect the changes both vertically and horizontally on our ordered pairs. All right, next activity. It says, consider the point xy is located anywhere in the first quadrant. For 1, it says, consider each translation of the point xy and the coordinates, description in the table, and record the coordinates of the translated points in terms of x and y. So if we went 3 units to the left, we're moving in the x direction. So going left and right is the x direction, and left would be decreasing. So the x would be -3, and the y would be unchanged. If we went 3 units down, the y is decreasing. So x would remain unchanged, and we'd have y -3. For the next one, 3 units to the right, so right and left is x, right is going up, so x +3, and the y would remain unchanged, and 3 units up is now increasing the y. So the x remains unchanged, and the y increases. So there would be our changes to those coordinates based on those transformations. Left and right is moving in the X direction. Right is up, positive. Left is down, negative. Up and down is in the Y direction. And moving down is the negative direction, and up is the positive direction. All right, describe a translation in terms of X and Y that would move any point, so that original point in quadrant X1 into each of those quadrants. So to move to quadrant 2, we got to move in the X direction to the left. So we got to go down whatever the X values units are. So if we're like at the X of 2, to get into that other quadrant, we got to move more than 2 left. So the X would have to move more than X units left. Okay, we'll go down to quadrant 4, then we'll go over to quadrant 3. So for C, to get quadrant 4, the Y would have to move more than Y. Ooh. Pencil messed up there. Let's try that again. More than Y units down, because you're moving in the negative Y direction. And then combine those to get in quadrant 3. We have to go left and down. So X, so it's kind of a combination of those two. Move more than X units left, and the Y would have to move more than Y units down. All right, so looking at another figure here, let's consider triangle ABC shown on the coordinate plane. Question 3, use the table to record the coordinates of each of the vertices of each translated triangle. So now we're not going to draw it. We're just going to move the vertices to get the points of the new image. So translate ABC 5 units to the right. So if we're going to move 5 units to the right, that means each X value needs to go up by 5. So keeping that in mind, so the new A, if we move that 5 units to the right, the current X value is -3. So if we do -3 plus 5, we're at 2. So that'd be 2, and the Y would remain unchanged. So the new B, the old B, is at an X value of -6. So when we add 5 to that, we're going to be at an X value of -1, and the Y remains unchanged. And then for the C, the current value is at points at -4, 9. So if we add 5 to the X, 5 plus -4, we're now at an X value of 1. So there's our new point. Okay, for the next one, I'll do the same thing, but I'll even write out the rule. So now it says we're going to take that same triangle and move it 8 units down. Okay, well, the original A is at -3. Ooh, lost all what I just wrote. All right, that's all right. We'll go back. So the original A is at -3, 4. So if we got to go 8 units down, we're going to be at -3 and then 4 minus 8. So our new A value, when we move that down, is going to be at -3, -4. And that's the process we're using to find each point. So for B, the original B is at -6, 1. So we're going to move that to -6, 1 minus 8 to go 8 units down. So our new B value is at -6, -7. And then for C, the original C is at -4, 9. So we're going to move that. X is unchanged. Y value is going to go down by 8. So 9 minus 8. So our new C is at -4, 1. Okay, so that's the process we're using with the translation down to fill in those points. And again, I'll go back and rewrite these. I know those just disappeared on us. So our new A, when we went 5 units to the right, was at 2, 4. Our new B, when we went 5 units to the right, was at negative 1, 1. And our new C, when we went 5 units to the right, was at positive 1, 9. All right, moving on to our next page. And I just filled those in on the previous page, is what we wrote out, but we'll write them again here just to fill in our table so it corresponds to what we're looking at. So this point, 2, 4, negative 1, 1, 1, 9. And then for the one we went 8 units down, our points were negative 3. I'll move it up here where we can even see it. Negative 3, negative 4. B was at negative 6, negative 7. And C was at negative 4, 1. All right, question 4 now. The vertices of triangle DEF are negative 7, 10, negative 5, 5, and F is at negative 8, 1. If triangle DEF is translated right 12 units, what are the coordinates of the vertices of the image? So again, right is in the X direction, so it's a positive 12 movement. So we're going to have to add 12 to each one of these X values. And if we do that, our new D value, if we add 12 to the negative 7, is at 5. So 5, 10. Again, the Y is not changing because we're just moving right. Our new E value is at 7, 5 when we add 12 to the negative 5X. And our new F value, when we add 12 to the negative 8, it's going to be at 4 for the X and 1 for the Y. So how did you determine the coordinates of the image without graphing it? We added 12 to the X values. C, if triangle DEF is translated 9 units up, what are the coordinates of the vertices? So now we're going in the Y direction and we're going up. We'll change color here. So we're going to have to add... wrong one. I thought I was on my pen. There we go. We're going to have to add 9 to each one of these Y values and do the same process. So now your new D, put 2 marks here. If we move it 9 units up, is going to be the X is unchanged, negative 7, and we're adding 9 to the 10, so 19. And same process for each one of these. X value is going to be unchanged, and we're going to add 9 to the Y value, and that would be 14, 5 plus 9. And then F, again, the X value is unchanged, and we are going to add 9 to the Y value and get 10. So how did you determine the coordinates of the image without graphing again? So we moved up, so we moved positive in the 9 direction. So we added... and it all disappeared on me again. That's okay. So you can always rewind the video if you were still writing that. I must have hit erase on that. So we added 9 to each Y value. Again, so if you were behind on writing that, just rewind the image to before. That all deleted on me there. All right, moving on to Activity 3.3, verifying congruency. So one way to verify 2 figures are congruent is to show that the same sequence of translations moves all the points of one figure. So they gave us 2 quadrilaterals here. So it wants to write the coordinates of CDEF, the pre-image, and then the coordinates of the new image. Okay, well, if we do that for CDEF, the original pre-image, keep my pin back up here. C is at 1, 2. D is at 3, 1. E is at 2, negative 1. And F is at 0, 1. And the new quadrilateral Those are at negative 4, 4. Negative 2, 3 for the D. Negative 3, 1 for the E. And negative 5, 3 for the F. So the translation on all of those, if you like look at C, to get from an X of 1 to an X of negative 4, it moved negative, so left 5. And to get from a Y of 2 to a Y of 4, it moved up 2. And you'll notice on all of these, that is the exact same. So if we have the same movement of each vertice, we retained congruency. So is quadrilateral CDEF, the original image, congruent to the quadrilateral CDEF of our new image? Yes. And how do we know? Same sequence. Of movements. All right, 3, describe a sequence of translations that can be used to show that figure A and new figure A are congruent and that figure B and the new figure B are congruent. Show your work and explain your reasoning. So, for A, if you were to measure each one of those transformations, you would find that, yes, they are congruent. And each movement, if we go like from this point to the corresponding point, is down 1, 2, 3, 4, 5, and left 1, 2, 3, 4. So all points moved down 5, left 4. And I think I actually started from the new image, so you should actually reverse that. But same point still applies. Okay, then to get from B to the new B, for figure B, yes, they are congruent still. And I'll do it correctly. I'll go from the original image to the new image. And for this one, if we pick out a corresponding point, it moved vertically 1, 2, so up 2, and then right 1, 2, 3, 4, 5, 6. So up 2, right 6. And if you measure each one of the points, they all did the exact same. So B is congruent. Okay, so I would encourage you now to probably pause the video, go through and see if you can do the same for all the other figures, and then come back and check to see if you got it right. Okay, so coming back for letter B, A is congruent. And our movement there was down 1, 2, 3, 4, 5, and right 1, 2, 3, 4, 5. So down 5, right 5. Oh, why did that disappear on me again? Again, rewind the video if you lost that. I don't know why my image keeps erasing previous page, so rewind it if you were behind filling that in. So it is congruent, and our movement was down 5, right 5. My pen might be getting a little low on battery. Okay, for B, you would find again that they are congruent. And our movement on B, original image is this one down here. So to get to a corresponding point, I'll say this one. Movement is up 1, 2, 3, 4, 5, 6, and right 1, 2, or sorry, left 1, 2, 3, 4, 5. So up 6, left 5. And all points, again, if you measured it, would all be the exact same, up 6 and left 5. That's how we can measure congruency. All right, if we move down to question 4, for each example, decide whether the figures given are congruent or not congruent using translation. Show your work. So again, you could do the same thing. You could also notice other things. If we're looking at figure A, you could even notice like this one corresponding side, those are different lengths. Well, if they're different lengths, the vertices didn't move the same amount up and left to get from one figure to the other. So this one is not congruent. For For figure B, and again, I'd encourage you to pause these, try these on your own. For figure B, you're going to find they are congruent. And it's because they all did move the same amount. If you measure the difference, 1, 2, 3, 4, 5 right, 1, 2, 3 down. They all move the same, 5 right, 3 down for each vertice. And then again, you could use what I showed you on A. Yes, again, you can count corresponding points, but even notice that these corresponding sides are not the same. So it's not congruent. All right, last page looking here. Suppose the point XY is translated horizontally C units. How do you know if the point is translated left or right? Well, if C is less than 0, meaning it's a minus, on the x-axis, that's to the left. So that movement is left. If C is greater than 0, so a positive movement on the x-axis, that is to the right. So write the coordinates of the image of the point. So it would look like this. X plus C, and then the Y would remain unchanged. If C was negative, it would be X plus negative C, so it would move to the left. And then suppose the points X, Y is translated vertically, D units. How do you know if the point is translated up or down? Again, if C is less than 0, on the y-axis, that is a downward movement. And if C is greater than 0, a positive number, on the y-axis, that is an upward movement. So the coordinates of the image of that point, this time the x would remain unchanged because we're moving up and down, and it'd be y plus C. And then 3, suppose that a point is translated repeatedly up 2 units, right 1 unit. Does the point remain on a straight line as it is translated? Yes. You're describing, essentially, if you think of slope, you're moving up, vertical change, a horizontal change, the same difference each time. If a point moves up the same amount, to the right the same amount each time, that point is going to remain, those are going to remain in a straight line. And last page, question 4, can you verify these two figures are congruent using only translations? And the answer there is no. If you notice, if you're looking at the original image ABC and the new image of ABC, the vertices do not coordinate with each other. One has been flipped over. So we can't simply slide it and translate it. We'd have to flip it over an axis of symmetry. So no, we cannot use translations only to determine congruency. That doesn't mean they're not congruent. It just means we cannot use translations to determine congruency.